For question 1, start with the left-hand side, which is 4 and 2/3 divided by 1 and 5/6. Let's convert both fractions into improper ones, so 14/3 divided by 11/6. And I'm going to flip the second fraction and change division to multiplication, so times 6/11. Now I can cross out the 6 with the 3 and then simplify. This will give me 28/11, and this is equal to 2 and 6/11, which is equal to the right hand side. In question 2, I'll start by plotting point 1 minus 1, which is here. Then to rotate triangle A by 180 degrees, note that from the center, which is this point, to go to this corner of the triangle, that's 2 units to the right and then 2 units up. If you rotate this by 180, it's going to be 2 units to the left and 2 units down. So this is where the new point is. Once you know this point, you can easily figure out that this is how the triangle will look like. And then for part B, for the translation by the vector -7, 3, take again any corner of triangle A. I'll take this one, so translate this one by 7 units to the left and then 3 units up. So this is where the bottom left corner will be. So again, you can easily draw this triangle. For part of question 3, I will start with the inequality I'm given, and then I will divide all sides by 2. So I'll get -4 less than y less than or equal to 1, but I need the integers because y is an integer, so all the integers in this range are -3, -2, -1, 0, and 1. Note that 4 is not included. For part B, this number line starts at -1, which is not included, goes to infinity, so I need all the numbers x that are bigger than -1. In question 4, you take your compass and open it at a random radius, place the pin at A and draw an arc that cuts both lines A and B and AC. Then repeat this procedure, but this time move the pin of the compass at this point and make an arc. Repeat with this point here, make another arc, and then finally join point A to the point of intersection of the 2 red arcs. And this black line is the bisector of the angle BAC. In question 5, I'll start by setting x equal to 0. So 5 times 0 plus 2y is equal to 10. This goes away. Y is equal to 10/2, which is 5. So I've got the point 0, 5. That's the y-intercept. And when y is equal to 0, I've got 5x plus 2 times 0 is equal to 10. This goes away. 10 divided by 5 comes out to be 2. So 2, 0 is the x-intercept. So now I can plot those 2 points and then join them with a ruler to get the required line. Note that the line must be extended to the left up to x equals to -2 at least, and then to the right at x equals to 4 at least. This is because of the restriction we have here. Now, as an alternative method, you can do the following. Rearrange the equation to get y on its own, and then make a table of values from -2 up to 4, find the y coordinates, plot all of them, and join them using a ruler. And question 6, I've got a bag with red, blue, green, and yellow counters. There are x plus 7 red, x minus 11 blue, and 3x green. The probability I take a red is a quarter, so x plus 7 over the total, which is given as 80, must be equal to a quarter. So if I cross multiply, I'll get 4x plus 28 is equal to 80. So 4x is equal to 52. X comes out to be 13. Thus, I have 20 reds. I've got 2 blue, and I have 39 green. If I add this, I will get 61. Therefore, 80 minus 61 comes out to be 19, and this is the number of yellow. Now I need the probability that Jude takes a yellow, so this probability will be 19 over 80. For part A, to find the highest common factor of these two numbers, I'll first convert them into a product of prime numbers. So let's start with 200. Let's perform consecutive division with prime numbers. 200 by 2 is 100, divide by 2, 50, divide by 2 is 25, divide by 5 it's 5, and finally divide by 5 gives you 1. So 200 is equal to 2 to the power of 3 times 5 to the power of 2. Now let's repeat for 420. Divide by 2 gives you 210. Divide by 2, that's 105. Divide by 3, you get 35. Divide by 5, you get a 7. And finally divide by 7 to get 1. So 420 is 2 to the power of 2 times 3 to the power of 1 times 5 to the 1 times 7. So to find the highest common factor, you multiply all the common prime numbers to their lowest powers. So I get 2 to the power of 2 times 5 to the power of 1. This will come out to be 20. Note that the mark scheme accepts both 20 and the product of the prime numbers as final answers. For part B, to find the lowest common multiple of these three numbers, I'll just find the product of all the prime numbers that appear in these three numbers and raise to the power of the highest power. So I get 2 to the power of 3 times 3 to the power of 2 times 5 to the power of 2 times 7 to the 2 times 11 to the power of 1. And I'm going to leave my answer like this. For question 8, I will need to use the following formula. Mean is equal to the sum sigma x divided by the number of students, which is n. Now if you rearrange this formula, you will get sigma x, which is the sum, equals mean times n. Now we'll summarize all the information on a table. Now let's enter all the information on this table. I've got 32 students in class A. I've got 28 students in class B. Total of 60 students. The mean of class A is 55 and the mean of class B is 52. And I need to find the mean for all 60 students, which is this one here. Now I cannot add the two means to find what I'm looking for, so I will have to work with the sums. So the sum for class A is 32 times 55, which is equal to 1,760, and the sum for class B is 28 times 52, which is equal to 1,456. So the sum for all 60 students is 1,000 1,760 plus 1,456, and this gives me 3,216. Therefore, the mean for all 60 students is 3,216 divided by 60. This comes out to be 53.6, and that is my final answer. For part of question 9, I will work with the following formula. Final amount equals initial times the multiplying factor. Now, because I get a 4% increase every year, my multiplying factor will be 100 plus 4, which is 104 over 100 to the power of 3, because I've got 3 years. So that's 1.04 to the power of 3 as a decimal. Hence, the final amount will be 2,000, which is the initial, times 1.04 to the power of 3. Plug this into the calculator, and this will give you 2,249.728. We want this to the nearest integer, so that's 2,250. For part B, again, I'm going to use the same formula. This time I have a decrease of 9% for 1 year. So my multiplying factor this time is 100 minus 9. So 91 over 100. As a decimal, that's 0.91. Power of 1, since it's just once off. So final amount this time is 1,365. Equals the initial, which is t times 0.91. Therefore, t is equal to 1,365 divided by 0.91. Put this on the calculator, it's going to give you 1,500. For question 10, I'll need to find the density of solid C, and the density is equal to mass over volume. So I'll need to find the mass and the volume of solid C. Now I have information about A and B, so I'm going to summarize all these on a table. I'm given that the mass of A is 2,000, the mass of B is 3,375. Therefore, the mass of C is 2,000 plus 3,375. is equal to 5,375. I'm also given that the volume of solid B is 450. I'm not given the volume of solid A, but I'm given that it is a cylinder, and the volume of a cylinder is pi r square h. Therefore, pi times 3 square times 7. This will come out to be 63 pi. Let's transfer this on the table. Therefore, the volume of solid C is 63 pi plus 450. Now, the density of solid C is equal to the mass of solid C divided by the volume of solid C. The mass is 5,375 and the volume is 63 pi plus 450. Put this on the calculator, you will get 8.3 to 1 decimal place. For question 11, the 5 sides of the regular polygon are the following. And to find the number of sides of the polygon, I will work with the exterior angle, and more specifically this one. And to find this green angle, I'll use the fact that I have parallel lines and hence corresponding angles. These two are corresponding. So let's start with finding angle TSC, which is this one. So TSC is equal 180 minus 128 equals to 52 degrees. That's because angles on a straight line add up to 180. And then I will use the corresponding angles. These two are equal because of the parallel lines. So DCU comes out to be the same as TSC, which is 52. And then I will work out this green angle, which is the whole of this minus 32. So DCV equals 52 minus 32, which is equal to 20. And now I'm going to use the formula for the exterior angle. So 20 equals to 360 over n. So n is equal to 360 over 20. So n comes out to be 18, which is my final answer. For part of question 12, note that y to the 0 is just 1. So this is 2 over 1, which is just 0. Part B, I'll split 16 and a to the 4. So 16 to the power of 3 over 4 times a to the 4 to the power of 3 over 4. The first part gives me 8. And for the second part, just multiply these powers and you get a to the power of 3. For part C, I will first expand the two brackets. So 5x times 6x squared minus 3x plus 8x minus 4. Let's simplify this bracket. 6x squared plus 5x minus 4. And now let's expand the whole thing. 30x to the power of 3 plus 25x squared minus 20x. For question 13, I will work with the multiplying factors of length and width. Now the length is increased by 20%, which means that the multiplying factor for the length is 120 over 100, which is 1.2 as a decimal. And then for the width, there's a decrease of 35%. This corresponds to a multiplying factor of 65 over 100, which is 0.65. Now the initial area is L times W, and the area after the increase is equal to 1.2 L times 0.65 W. Now if you multiply those two numbers, you'll get 0.78 L times W, and note that LW is the initial area, so the area after the increase is 0.78 times the initial area. Now you have experience with multiplying factors. You should recognize a multiplying factor of 0.78 corresponding to a decrease of 22%. If you are not, then we'll have to do some extra workings. Let's use the formula for the multiplying factor. This is equal to 100 minus k, which is the percentage decrease, over 100. We know it's a reduction. We're being told that in the question. So 100 minus k over 100 is equal to our combined multiplying factor. Cross multiply. 100 minus k is equal to 78. So bring k to the right. 100 minus 78 will give you a percentage decrease of 22. For question 14, to find the perimeter, I'll first need to find the length of the major arc AC, which is this one. Now to find this, I will need the angle at the center, but not the small one. I'll need the reflex one, so I'll need this angle here. So to find that one, I'll use the fact that the angle at the center is twice the angle at the circumference. So if I label this as theta, then theta is equal to 132 times 2, which is 264 degrees. Now, major arc AC equals theta over 360 times 2 pi r. So 264 over 360 times 2 pi times 8.5. This will give me 39.165 and so on. Therefore, the perimeter is this number plus 8.5 plus 8.5. Put this on the calculator and the answer comes out to be 56.2, correct to 3 significant figures. For part A of question 15, to find the interquartile range, I can use the standard formula I use for the interquartile range and the quartiles, which are the following. First, you find a quarter of 11, which is 2.75. So Q1 is the third one. You round up to the next position, and the third one is equal to 2. So that's the lower quartile. Repeat with 3/4 of 11. This comes out to be 8.25. Again, we round up, and rounding this up is the 9th observation. Now the 9th observation is 11. Therefore, the upper quartile is 11. Finally, interquartile range is equal to Q3 minus Q1. Therefore, 11 minus 2, which gives me 9. Alternatively, you can say that this is the middle, this is the median, and then if you split the data set left and right, this 2 is the middle of the left part and the 11 is the middle of the right part. In part B, we are given Kim's median and interquartile range, and we are asked to find who served more aces on average, and the answer is Kim, since her median is greater. And for part II, who was more consistent with the number of aces? Consistency has to do with the interquartile range. Kim has a smaller IQR, therefore she is more consistent. For question 16, to find AC, I need to create a path from A to C. I'll start from A and go to B, and then continue from B to C. I don't have AB, but I have BA, which is exactly the reverse. So A and B is 5 minus 4. BC is given as 9, 1. So if you add this element by element, 5 plus 9 is 14, minus 4 plus 1 is minus 3, and this is my final answer. For question 17, in order to draw the histogram, I'll need to find the class width and then the frequency density. So I will add 2 extra columns to my table. The class width is the difference between the upper bounds and the lower bounds of each category. So for the first one, 25 minus 10 is 15, and then I get a 5, 20, and 10, and the frequency density is equal to the frequency divided by the class width. So 15 divided by 15 is 1, 18 divided by 5 is 3.6, 32 divided by 20 is 1.6, and 4 divided by 10 is 0.4. So let's draw these bars. Now for part B, I'm being told that one of the students who took between 25 and 50 is chosen at random. I need the probability that this student took 45 minutes or less. Now this is a conditional probability problem, and I will start by finding the number of students between 25 and 50. So let's go back to the histogram, I need the following students. Now I don't need to do any calculations for this because I have this ready from the table above. So 18 and 32 makes 50. Let's write this down. 18 plus 32 equals 50. So that's my denominator. For the numerator, I need the number of students with t less than or equal to 45 out of those 50. So let's go to the histogram and shade this region. Out of those blue, I need the ones that are less than 45. So this is what I need. Note that I need the whole of the second bar and 3/4 of the third one. So I need the 18 and 3/4 of 32. So let's write this down. So 18 plus 3/4 of 32. This is 42 students. So now to find the probability, I just need 42 out of 50. This is equal to 0.84, or as a percentage, 84%. Any answer of those three will give you the marks. For question 18, I have a situation of two similar shapes. So I will create the table I usually do for this type of questions. So I've got the model and the statue, I've got length, area, volume. Length has a scale factor of k, area k squared, and volume k to the power of 3. Let's transfer all the information I have on this table. So the area of the model is 625. The area of the statue is 3600. And the volume of the model is 750. I need to find V, which is the volume of the statue. Now I will use this fact that the area and the statue have specific volumes. So let's use those volumes to find K. So 625 times K squared will give me 3600. So K will be 3600 over 625, and then I'll take the square root of that. This comes out to be 2.4. So now I can use that K with this volume to find V. So V equals 750 times 2.4 to the power of 3. Put this on the calculator. V comes out to be 10,368 centimeters cubed. For question 19, there are various ways to show this. I'll do it using 3 different ones. So that for the first one, I've got 2k, 2k plus 2, and 2k plus 4. The 2k is there to make sure that whatever k is, doubling that will give me an even number. Now my target is the following, and that's the middle number squared times 2 plus 8. So let's take the first one, square it, plus the third one, square that, and let's expand. 4k squared plus 4k squared plus 16k plus 16. This gives me 8k squared plus 16k, and then I'm going to split the 16 into plus 8 and plus 8 because the last term of my target is plus 8, so I need this to be at the end. So from the first 3 terms, I'll take out a common factor of 2, not an 8, a 2 because this is what my target tells me to do. So 2, 4k squared plus 8k plus 4 plus 8. And then you just need to recognize that this, when factorized, gives me this term squared. So 2k plus 2 squared plus 8 as required. For the second method, my three numbers will be 2k minus 2, 2k and 2k plus 2. The target this time is the following. So again, take the first one, square it, plus the third one squared, and then expand. So 4k squared minus 8k plus 4 plus 4k squared plus 8k plus 4. You can cross out the 8k and the minus 8k. This will give you 8k squared plus 8. Now this plus 8 is the one needed at the end. So I'll split the 8k squared into 2 times 4k squared plus 8. And then just recognize that 4k squared is the same as 2k all squared. And this is what I was meant to get as required. For the third method, I'll let my numbers be k, k plus 2, k plus 4. But this time I have to specifically mention that k is an even number. Now, if I don't mention this one, then the whole of the proof is invalid. So again, squaring the first one plus the square of the third one and expand k squared plus 8k plus 16. So 2k squared plus 8k, and again, split this into plus 8 plus 8. Factorize the first three terms. So 2k squared plus 4k plus 4 plus 8, and finally factorize to get k plus 2 squared plus 8, which is 2 times the middle number squared plus 8 as required. For question 20, I need to complete this Venn diagram. Now starting from the first statement, the triple intersection, which is this one, is equal to 5. A intersection B intersection C, that's the intersection of A and B without the C. So this is the region I'm referring to, and this is equal to 2. Now A intersection C is 5. A intersection C is this region, and since I have a 5 already there, it means that the one next to it is 0. Next statement, A has 17 elements. This is A, so all the numbers in here must be 17. I already have 2, 5, and 0, so I'm missing a 10 here. Now for the next one, I've got A union B union C dash is equal to 3. Now A union B union C is this region here, so the complement of that is the outside, and the outside is equal to 3. Next, I have A dash intersection B intersection C dash. That means B without everything else, which is this region, is equal to 6. Then the intersection of B and C, which is this one, is equal to 7. That means that I have a 2 here. And finally, the whole of C is 14. I already have 7 there, so I'm missing another 7. For question 21, I will need to draw the tangent to the curve at point P. This is a straight line that just touches here, so it's going to be something like that. And then I'll need to find the gradient of this line. I'll need to take 2 points on this line. Now I'll take these 2 points. Let's write the coordinates down. So I've got -8, -1, and 4, 6. So to find the gradient, I'll use the following formula. So let's substitute the numbers. So 6 minus -1 over 4 minus 8. This gives me 0.58. Now note that the mark scheme accepts any value between 0.2 and 0.8. For question 22, I will rearrange this equation into the following: y equals minus 2x minus 3, and then I will replace this y with minus 2x minus 3. So I will get 2 minus 2x minus 3 squared plus x squared equals minus 6x plus 42. Let's expand. 2 times 4x squared plus 12x plus 9 plus x squared equals minus 6x plus 42. Further expansion will give me 8x squared plus 24x plus 18 plus x squared equals minus 6x plus 42. Let's take everything to the left. 9x squared plus 30x minus 24 is equal to 0. Note that all terms are divisible by 3. So let's divide by 3 to simplify. 3x squared plus 10x minus 8 is equal to 0. Now I need to solve this equation. You can use factorization, completing the square or the quadratic formula. I'll go with factorization and get 3x minus 2 times x plus 4 is equal to 0. So x is equal 2 over 3, or x equals minus 4. Then substitute these x values into that blue equation at the top to get y equals to minus 2 times 2 over 3 minus 3. So y is minus 13 over 3, or y is equal minus 2 times minus 4 minus 3. Y comes out to be 5. So my two pairs are the following, and that's the final answer. I'll start question 23 by finding the value of x, and to do so I'll use intersecting chord theorems, and the two chords I'm going to use are the following. Point of intersection is E, so the formula is the following: EA times EC equals to EB times ED. So let's substitute the expressions in. X plus 5 times 5x minus 12 equals to x times x plus 12. Let's expand. 5x squared plus 13x minus 60 equals to x squared plus 12x. Let's take everything to the left. So 4x squared plus x minus 60 is equal to 0. You can solve this quadratic by either factorization, completing the square, or using the quadratic formula. I will factorize and get 4x minus 15 times x plus 4 equals to 0. So x is 15 over 4, or x is equal to minus 4. Now note that x must be such a value that gives me positive lengths, and the minus 4 will give me negative lengths. So I'll keep the 15 over 4 as a decimal. This is 3.75. So let's go back to the shape and proceed. Now to find the angle ADE, I'll need to use the sine rule with the following triangle. So let's extract this triangle and add all the details on. Now x plus 5, which is AE, using the 3.75 gives me 8.75, and the DE, which is x plus 12, comes out to be 15.75. So now let's use the sine rule. 8.75 over sine of d equals to 15.75 over sine of 48. So if you cross multiply, sine of d is equal to 8.75 sine of 48 over 15.75. This comes out to be 0.412 and so on. Therefore, d is the inverse sine of 0.412 and so on. Use all the digits on your calculator, and if you put this on the calculator, you're going to get 24.4 degrees to 1 decimal place. Now for question 24, I will start from the end. I'll start with what I need to find, and I need to find the total surface area of the cone and show that it is equal to this expression. Now note that this expression has no h, which is the height of the cone, has no L, which is the slant height of the cone. So I'll go to the last page and write surface area is equal to pi r squared, which is the circle at the base, plus pi r L. So my first target is to find an expression of L in terms of K and R. Now, if I go to my shape, I can construct a right angle triangle here. So I can use Pythagoras theorem and say L squared is equal to R squared plus H squared, but I shouldn't have H in my final answer. So in order to get an expression of H in terms of R and K, I'll have to use what I'm given, that K times the volume of the cone equals the volume of the sphere. So let's use that. Now the volume of the cone is equal to 1/3 pi r squared H, and the volume of the sphere is equal to 4/3 pi r to the power of 3. So K times volume of cone equals volume of sphere. So K times 1/3 pi r squared H equals 4/3 pi r cubed. Let's cancel out the over 3. Let's cancel out the pi, and let's cancel out some of the r's. The r square goes away, and here I'm left with an r. So K times H equals 4r. So H is equal to 4r over K. So now I can go on the side and use Pythagoras theorem. L squared is equal to R squared plus H squared. So L is equal to the square root of R squared plus, and instead of H, I will use 4R over K squared. So L is equal to R squared plus 16R squared over K squared, square root of that. Let's write this as a single fraction. So L is equal to R squared K squared plus 16R squared over K squared, square root of that. Now I will factorize, take out a common factor of R squared, and I'll get K squared plus 16 over K squared, square root of that. Now I can apply the square root separately on the R square, the bracket, and the K square, and if I do so, I'll get the following: square root of R square times square root of my bracket over square root of K square, and this will give me R square root of K square plus 16 over K. So now I can take this and go to the formula for the surface area. So I get pi r squared plus pi r, and instead of L, I will get R square root of k squared plus 16 over k, and I'll try to make this 2 as a single fraction. So I will multiply the first by k and get k pi r squared plus pi r squared square root of k squared plus 16 all over k. So let's factorize. Let's take the pi r squared out as a common factor. So pi r squared, I'll be left with k plus the square root of k squared plus 16 all over k as required. I will start question 25 by drawing a rough sketch of this shape. Now note that I have labeled F the point of intersection of the line of symmetry NAB. Everything else is as described. I'll start by finding the gradient of AB using the following formula. Substituting the values in gives me 6 minus 3 over minus 4 minus 2. Put this on the calculator and you'll get minus 1 over 2. Then I will find the coordinates of point F, which is the midpoint of AB. I will use the following formula. So F equals to minus 4 plus 2 over 2, comma 6 plus 3 over 2. Simplify this and you'll get minus 1 and 9 over 2. Next, I'll find the gradient of the line FE, and FE is perpendicular to the line AB, and I know the following for perpendicular lines. So the gradient of FE is equal to minus 1 over minus a half, which will give me positive 2. Therefore, to find the equation of line FE, I will do y equals mx plus c. I'll use the gradient I found, which is 2. X value is minus 1, y value is 9 over 2. This will enable me to find the c, and c comes out to be 13 over 2. So the equation is y equals 2x plus 13 over 2. Now I will find the equation of line CD. Now the gradient of CD is equal to the gradient of AB. Since these two lines are parallel, so gradient is minus a half. I found this above. So to find the equation of line CD, I will use y equals mx plus c again. M is minus a half. And the point of CD I'm going to use is point D, which I know it's minus 1, 8. So 8 is equal to minus a half times minus 1 plus C. This will give me a value of C of 15 over 2. Therefore, y equals minus a half x plus 15 over 2 is the equation of the line CD. So now I will solve simultaneously these two equations. So let's go on the next page. 2x plus 13 over 2 equals minus a half x plus 15 over 2. I'll take this to the left and the 13 over 2 to the right. So I'll get 5 over 2x equals to 1. So x is equal to 2 over 5. Substitute these into any of those equations. 2 times 2 over 5 plus 13 over 2 will give me 73 over 10. And these are the coordinates: 2 over 5, 73 over 10. For question 26, I'll start from the multiplication, and I'll need to factorize the two numerators and the second denominator. So x minus 5 times 4x plus 3 over 2x minus 1 times x minus 3, 2x minus 1 over x minus 5x plus 5. And now I can cross out the 2x minus 1 with the 2x minus 1 and also the x minus 5 with the x minus 5, and I'll be left with 4x plus 3 times x minus 3 over x plus 5. So let's go to the original expression. 4x plus 3 times x minus 3 over x plus 5 plus 29 minus 4x. I'm going to write this as a fraction over 1. I'll need to multiply the second fraction by x plus 5. So now we'll get 4x plus 3 times x minus 3 plus x plus 5 times 29 minus 4x, all these over x plus 5. So let's expand and simplify. 4x squared minus 12x plus 3x minus 9 plus 29x minus 4x squared plus 145 minus 20x, and all of these over x plus 5. I can cancel out the 4x squares, and now let's simplify the x's. Now you try and do that, you will notice that the x's cancel out, so adding the numbers will give you 136 over x plus 5, which is the final answer.